Hi, I'm Brian, and I'm joined by Sanjay. Today, we're going to go through designing cloud-native .NET applications. From the agenda perspective, we're going to start with what is a modern app? What's the benefits? Why do we want to do it? We'll look at a little bit about, what kind of characteristics make that up. We'll move on to the greenfield design that we came up with, that we wanted to build to meet our needs. Then we're going to look at the steps and decisions that we made, which actually changed the app a little bit from our initial design. And then we'll look at that app that we built. And then at the end, we're going to give you the link to the source code. So you'll be able to play with this. We've got it set up well in Visual Studio. We've got best practices created. So you can go play and look at all the different services in AWS that we use. So if we talk about why build a modern application, the reasons are to make a bigger, better, faster, stronger app. And when I say that, it's really about agility, right? We want cost reduction. We want improved security. We want to not patch servers. We want to do all these different things if we can. There isn't a right way to build a modern app. There's wrong ways to build, and that's one of the things that we'll give guidance on, and you can learn on what things you probably shouldn't do. But there's not a specific right way to build it. We're going to go through one way that we built ours, and it really does give that CI/CD pipeline, the agility, accelerated innovation, horizontal scale, even worldwide scale. So that's why we build it. If we take a look at some of our customers, a customer example, my favorite is Netflix. And, if we look at Netflix, I mean, one of the things that is they consume on a general Friday evening, they push out 1/3 of all traffic in the United States on the internet, which is just an amazing, number in itself just for that customer. And they're pushing that out of AWS. At the same time, there's lots of other customers doing other things. And so that is impressive in its scale. But what about deployments? I mean, Netflix does some other interesting, unique things. Our app isn't going to be designed like Netflix, but what these modern apps give us, and Netflix is a great case study of how to do that, they deploy thousands of times a day, right? That's amazing, right? From a traditional environment, we would deploy once or twice a year. Thousands of times a day is quite an improvement. Another thing they do is they have a self-healing design. So they actually have some things to test that. They have it's chaos engineering, and they've named a chaos monkey. They've got chaos gorilla, and they have chaos Kong that go to different levels of destroying their application while it's running in production to make sure that the self-healing works, which is kind of a fascinating thing. But chaos design is about, looking at your app when you're doing it at scale. It's not about if it's going to break. It's about when it's going to break. And how do we plan for those breaks, and how do we make those things happen? Matter of fact, there's a customer I had worked with who, when their alarms went off for their application, one of the tools they would use is they would bring up Netflix. If Netflix was up and running and available, they knew it was their problem. If Netflix was down, they were pretty sure it was an AWS problem. And so that's one of their decision criteria that they would utilize. That's how solid Netflix has been. So anyway, that's what we get from modern apps, is these types of abilities. And if we go look a little bit deeper at what we wanted to build, we looked for certain things that modern apps can do.
Yeah, and also when we started looking into this, right, Brian, when we talk about what we wanted to build, we wanted to build like a living reference architecture that customers can actually deploy in their environment and really see how modern application would look like, right? As most of the customers that we see are building more like a legacy application, it's kind of hard for them sometimes to really envision what a modern application would look like, right? How would they build this microservices? How would they deploy that microservices in a serverless Lambda, or maybe how will they deploy that in containers? So we wanted to have some application that can showcase how these applications are built. And not just on the backend side, we wanted to also build like a modern front-end application, like as you see on your left-hand side, where we wanted to build a modern UI application where you can build once and deploy your application in your web browser, or you deploy this on a mobile browser, or you want to build like a mobile app, or in the future you want to build like a streaming app, right? So we wanted to build an application that we can reuse the UI components and deploy it across multiple platforms. And also,
I was just going to jump in and say, when we looked at what should we build, for one, we're Microsoft focused technical people. So one, we wanted to build something Microsoft, right? We had different UIs to look at. We had different backends things to choose from. But we think about corporate enterprises, Fortune 1000 companies. 80% of them develop .NET applications.
Yeah.
So .NET is certainly an application we wanted to look at, and we want to bring best practices. So that's where we kind of started, is what can we do with .NET? And then, you look when you build an app, right? Again, there's no right way to build an app necessarily. There are wrong ways, but no right way. So what are we going to build that can showcase some of these things so you can learn and get this concept of a modern app? Are we going to do an e-commerce site, a streaming media site, that kind of stuff? We kind of want to do a single page application. That's a very common design with, serverless stuff on the back end. And so that's kind of what we looked at is, our business needs, our requirements to match to build this greenfield app is these things.
Yeah, and also like most of the customers, when they're building this modern application, right, they wanna really understand the observability of the application. That was also one of the core things what we want to build in our modern application, is to have an application that is serverless but has all the observability in it, right? So with that, I think that takes us to show what we built from a user perspective, right? Okay, with that, let's go into demo, and we'll talk about how easy it is to deploy your application. We have a one-click deploy to deploy your application right from our GitHub account. And we'll also talk about the modern front end that we have using Blazor. We'll also talk about the authentication using Cognito. With that, let's go into demo. And all the sample code that we have is readily available on our AWS sample account. So it's publicly available on GitHub, and you can go to this URL to actually download the code, fork the code, and actually deploy the application in your AWS account. And you can scroll down to how to deploy section and actually click on Launch Stack to deploy the application in your environment. And since I've already deployed this application in Ohio region, I'll select the different region to be able to deploy it. And let me just change my region to California region. Give it a second. Okay, here we go. So as you can see, the URL for the template is preloaded. So I'll click on next. I will ask for a few parameters to be passed. Essentially, the branch that you're using. Here we're using a main branch to deploy the application, the GitHub owner, and the repository where we're deploying it from. Also, we need to pass the GitHub token. Let's just pass the token to it so that the code pipeline can actually download the code and deploy it. With that, click on next and give it a permission to create IAM roles and create stack. So essentially, I will actually deploy the whole application, the whole infrastructure of running the application in your environment. And it may take a few minutes. So essentially, I'm going to go switch into the version of this application that's already deployed. And once the application is fully deployed, this is how would you see. Since I was playing with it, let me just log out from here. Okay. So essentially, once you go to your application, you will first ask you to be logged in. And this is powered by Cognito, right? Here you will be, either you can create your account if you don't already have, or if you forgot your password, you can reset your password. I already have a user that I can log in with. All right, so once you log in into your application, I will show up like this. Essentially, it's an image recognition app. What it does is it allows you to create a photo album, and then you can upload the photos to the album, right? And as you can see, I've created 2 albums already, demo and demo 1. So let me just create another one to show you how it looks like. Let's create a demo 2. And once you create a demo, once you create an album, it will show up in the list of albums, and then you can go to an album and you can choose the files or choose the photos to upload to the album, right? So let's go and do that. And here are 2 files. Let me submit those. So essentially what it's doing behind the scene is uploading those photos into an S3 bucket and then processing through a backend processing, right? And in the backend, what it does is it calls the image recognition API to show you all the objects that it detected, right? Here you can see me having fun with dolphins, and you can see, as the object detected, you can see the person and dolphin and the seaside, right? Here's Brian with his family. You can see it detects the labels and shows back, right? And also the great thing about this application is, as we talked about, building the modern SPA application, right, which is single page applications. And as you see, when I clicked on the button, it did not refresh the whole page, right? It only bring back the components that should have changed. So that's the application for you. And let's now go back to the slides.
Thanks, Sanjay. That's a cool demo. I thought that one-click install looked like 5 clicks, but still pretty easy to have that full app up and running with all the source code, the CI/CD pipeline, all that stuff. So best design of how to do things within Visual Studio in the code as well there. So some really great stuff. In addition to that, these are the technologies we've utilized, right? As you logged in, and as you said, it went against Cognito. And then we're uploading those photos that go to S3, and we're storing data that it got out of an API call to see that it was, people or a dolphin or whatever, and it add back those tags, right? That's being stored in DynamoDB as well. So, all these different things, if you're interested to figure out how to do an API call, how to run a Lambda function, how to have that observability within there, all that stuff is there, and a bunch of other backend services too. The other thing is, if you want to compare this, there's a Java application that does exactly the same thing. That's a reference application from AWS, and you can compare and contrast, what we did with .NET compared to what we have done with Java and Node.js as the backend. So here we're using .NET as the backend in the Lambda functions, and Blazor right in the front.
Yeah, and also we're using Blazor, right, as we're talking about. So essentially, just for the folks who are not familiar with Blazor, what Blazor is, essentially, it's a web framework that allows you to build interactive web user interface, as we saw, but essentially using C# and Razor instead of using JavaScript. Isn't that cool, Brian?
That is totally cool. And
Yeah.
when we decided to build an app, that was one of the big decisions, right? Should we use a React front end or something else, right, in Java? And it was like, no, we should see what Microsoft technologies are there, and if there are some, let's look at that. And so that was a big choice in that for us.
Yeah, and I think exactly as you said, right? It was using Java and we built into C#. So let's look at what the reference architecture of this application looked like that we deployed.
Yeah, this is what we wanted to build. And, this is very similar to that Java application I referenced, right? Mm-hmm. We have the files are held statically in an S3 bucket and delivered by a CloudFront, right? So very inexpensive, very scalable, right? It's basically files that don't change and very secure, right? So that gives us the client then, and then that client goes and it talks, via a technology to go talk to the back end. And so this is what we wanted, all in .NET, no Java. So that was the main design that we came away with of what we wanted to build.
Yeah, and all the Lambda function that we have also, right? As we talked about, when you upload a photo that processes the images, they're also built into Lambda. They're also built into .NET using C# and .NET Core. So with that, let's talk about some of the choices that we made, Brian, right? When we started to think about, how we wanted to build, and remember those whiteboard sessions we were doing and talking about, which single page application framework should we use, right? Should we use a JavaScript, like using a React, or should we use a Blazor, right? That is more of a modern Microsoft technology. And also we were having some choices to, which API should we use? Should we build it like a traditional REST API that is most common to build your backend applications? Or should we use a GraphQL using AppSync to be able to build a modern backend systems? So let's go and talk more about those, right?
All right, let's talk about why we chose Blazor.
Yeah, so also like as we talked about, I want to build this application using C# and most of my background has also been building .NET development, and so instead of learning a JavaScript, or instead of learning more of the newer or using front end React application or React technologies or Angular or Vue.js, right? For us, it was kind of let's be able to use the C# that we already know and we love. how about build a interactive web UI using C#? So that's one of the biggest reasons, I think, why we chose to go with Blazor.
And then we wanted to run in the browser as opposed to on the server because what's cool, it scales.
Yeah, and also as you just said, Brian, like run in the browser, right? Think about that, right? You are able to reuse your libraries that you have been able to build on the server, right? Essentially, what Blazor does is it actually implements .NET Standard, right? So if you have any libraries that you've built in .NET Standard and you're running on server, you can use the same libraries in the client and actually have a functionality running inside a browser, right? So that Blazor gives you the flexibility of sharing the code and have the same models across your client application and the server applications. And also, right, as we talked about initially, we're talking about building across platform applications, right? So Blazor, with the Blazor hybrid, allows you to build native applications that run on top of Mavi, right? So if you want to build a native mobile app or you want to build a native desktop app, you can reuse those Blazor components that you've built for your web application, and you can reuse the same components for your native applications. So those are, I think, the big reasons why we selected Blazor.
Yeah, but when we talked about running Blazor right in the browser, using that on top of WebAssembly, and there were some cool upsides to it, but there were also some downsides, right? Because the Java engine's already built in there, and so it doesn't have to download. But the Blazor engine is not. So
yeah, that's a great point, Brian. So essentially, as you just said, right? So essentially, what Blazor does is it runs on top of WebAssembly, and that is one of the kind of you can see as a consideration you want to consider is because essentially downloading the whole .NET runtime that builds on top of WebAssembly. So you might see some of your initial startup might be a little slower, right? Because now you're downloading the whole .NET assemblies at the first time when you're running the application. So you want to consider that building the Blazor applications.
Yeah, once it's down though, right? If it's down for our app or some other app, isn't it down in there? It doesn't reload every time.
Right. No, it's only the first load, and also as we're using a CloudFront upfront, right? So CloudFront will cache all those DLLs. So it's going to be cached to the closest node to the user end. But once it is cached, it's available for you. And once it's downloaded in your browser, it's not going to download every time. But the first initial load could be a little slower.
Still not as fast as Java will be because Java is already pre-installed.
Yeah, and also like if you already have, if you already have a Teams. Already have a skill that already know JavaScript, then you can definitely start to build your modern application using JavaScript. This is if you want to build whole .NET like from top to bottom, right?
Excellent.
Yeah. So let's now also talk about the REST versus GraphQL as we had that's choice, and most of us already know, right, what is REST, right? Essentially, what REST allows us to do is it allows us to do like a get, post, and put requests to a known endpoint, right? So let's say if you have a resource, I can get customer, I can update customers, right? And most of those requests are mostly like a JSON format where I will send the request and get back a JSON response. And the response that we get back in the REST APIs are mostly static, right? That is predefined schema that servers are already decided, and that is always the same response that you will get, right? And that is what the REST is. But when we do a contrast with GraphQL, what essentially GraphQL brings to you is essentially it gives a lot of flexibility to your customers or to your clients. So clients can ask for the data exactly what they want, right? So it solves the problem of underloading or overloading of the data that is being returned, right? So essentially what I mean to say is clients can request specific fields that they want, and the server will only return that field to you. Or the clients can add multiple fields that they want to show, and the server will return back to the multiple database, right? I think it will be better to show it with an example, right? So let's take an example here. Let's say you want to load a customer profile, but in your application you only want to show the phone number from the customer, right? If you're using a REST API, you will make a request to your profile endpoint, and you will get the whole profile of a customer, and the client will take the whole profile and parse it and just show the phone number, right, and throw away the whole JSON data, right? With the GraphQL, the clients can build a query to just get the phone number, and that is the only thing they will return back from the server, right? So they will not get the whole profile to just show the phone number, and that is the value that GraphQL brings to you, right? And
so
also
it saves some networking, right? It saves networking.
Yeah.
It saves processing. If you're on a mobile device, it doesn't have to take those things and put together. And even data, if let's say we want to give the phone number, but not the address, some savvy person like yourself could go in there and pull the address out of the JSON file. But with GraphQL, it's only going to return the data that we wanted to give it. It won't be any chance to see that.
Yeah, and exactly those are the reason why we chose to build a GraphQL application, right? That's what we wanted to build, is to only return the payload that is requested by a client, right? So as we were showing the demo, right, you saw we had an album, we had the photos, and we only wanted to return a thumbnail for the photo, right, and bring the objects. So we don't want to bring the whole photo object and bring the whole album where we just want to show just a few things that we want to show from the payload. And that's one of the reasons why we wanted to go for GraphQL. And also, as Brian mentioned about phone number and address, right? Essentially, what it means is we can get the data from multiple resources in a single round trip, right? So essentially, let's say if you want to show multiple parameters from, let's say, a phone number or a profile, right? So you can combine those in a single round trip, and the server will bring the data together, which also essentially reduces your round trips, improving the network, as Brian was saying.
Now, you had said so there were some other interesting things here from the perspective of the client, right? If I was going to have a client that is, if I own the client, GraphQL was kind of nice. Was there's other things there, I guess, that we've talked about with the API versus AppSync, is API Gateway versus AppSync, the AWS services, right? API Gateway does the REST API, and it's been around longer. We were looking at, it's been around since 2000 as far as the REST API. Our API Gateway has been around longer, and it's integrated into more AWS services. So there's that to think about. The AppSync is the other service from AWS that does the GraphQL, and it hasn't been around as long. So there aren't as many integrations into other services. Another difference is one is about $30 a month to run, and the other is about $40 a month to run. Or it could be 20 and 30. I probably should get those exact numbers. But it's about $10 different to run per month. And so, as we look at the technology, there are differences in the services behind it as well.
Yeah, and also as you touched on that, one more point there to add, Brian, as you talked about, like, do you own the clients, or you're building the services for the external client, right? And as you said, like, REST API has been out from a long time, so there has been more maturity of being able to like the client that you don't own, they can integrate with faster. With GraphQL, it's better to use if you own the client, right? Because you might have to use the JavaScript SDKs or JavaScript libraries to build the GraphQL request and send it to the server.
Yeah, and the tooling too, right? You found the tooling was on the REST API. There's a lot more tools out there for troubleshooting and working with it.
Yeah, definitely. Like for GraphQL, you can definitely use like few tools there, like Procmon, you can use that, or Postman, sorry. You can use a Postman to send the request to GraphQL. For your REST, you can use curl and other tools, right? So it's catching up, right? So I think GraphQL is a recent technology, but I think it's great to build your applications where you're bandwidth sensitive, or you're sensitive about how much data being downloaded, right? So I think these are some considerations that you have to look into as why you want to choose one technology versus the technology.
And that's why we wanted to use GraphQL, because it was newer. That's
exactly
it. It wasn't necessarily
well, and it's cool, right? It was
newer.
It definitely is. I think it's definitely a great technology to use towards. So I think that takes us to an interesting topic of technical challenges, right? Now we've talked through what we wanted to build. So essentially, when we started to build, right? So this is where the rubber meet the road. What happened and what challenges we had, and what were the lessons learned going around the way, right? So just going deeper into the lessons that we learned, or the challenges, like the first biggest lesson that we learned is when we started to build Blazor. Using WebAssembly, right? The first thing when we learned is the .NET runtime that's running on the top of WebAssembly is not the full .NET runtime, right? So you don't have all the APIs available in your Blazor that you would have running on your server, right? So that was the first technical challenge that we got. Essentially, what it means is when you're running a Blazor in a WebAssembly in a browser, .NET. Essentially, Blazor and WebAssembly does not have a support for cryptographic algorithms. Microsoft has mentioned they will definitely be looking to add support for cryptographic in .NET 7, fingers crossed. But till then, essentially, if you're looking to have a had an API for cryptographic, challenge you have is essentially you'll have to run that on the server.
Yeah, from the research we did, it seems like they were using an open source library that was rather large, and it just added time to pull that down into WebAssembly and download it and all that. So they chose not to go with it just because of the size of that. And they're looking at different workarounds to build their own cryptographic libraries that are smaller and that kind of thing. And hopefully it gets into .NET 7 so we can, have those signed API calls within the browser in Blazor.
Yeah, and just to add, right, why it matters a lot, right? Because as we know, most of the AWS API call that you do, it requires a signed header, right? So if you want to use AWS SDKs to, upload the photos to a S3 bucket, or you want to use Cognito, right? In those cases, you want to make your API calls, but it requires a signed header. And if with that, like with the Blazor with .NET 6, does not have the capability. So that was one of the first technical challenge that we got into.
And that brought us to Blazor on the server. so we moved it from in the browser and put it on the server. So therefore, it fixed everything, right?
Yeah. Well, I think it did, but it added different challenges, right? So I think one of the challenge that we learned, right, when we started to build, Brian, was when you run the Blazor on the server, it does make your front end look like a single page application, right? So it does not refresh your whole browser when you do a click. But what essentially it's doing is it's rendering your Razor components on the back end, and it is only sending back the updated UI. But it is doing it on the top of SignalR, which essentially requires a sticky session to be built when you use an application load balancer in the scenario that we use, right? So that's not one of the best practices to have a sticky session going around, but if you're running a Blazor on a server, that's one of the things that you will have to do for the SignalR technology to work. You need to have a sticky session.
And we wouldn't have had this problem at all if we had just gone with a single page application running, React framework or Vue.js or Angular, all of those routes we could have gone. We wouldn't have had this problem at all because they have the cryptographic library in Java, and we could sign all of our SDK calls and just work natively out of the browser.
Yeah, but I think one of the good reason of running this on a server is it's the same Blazor code, right? Once we have the .NET Sound, the cryptographic support, the hope is we should be able to run the same application, just compile it in a WebAssembly and run it, right? So it should not require us to change a lot of stuff. We're just waiting on once the cryptographic support is there and we can use our AWS SDKs. It should be able to run those in a Blazor in a WebAssembly, right? So I think it's good to be there, and then once we can go to WebAssembly, we can just host it over there.
And we wouldn't have learned near as much had we gone that route.
Right. Yeah, and also I think the other challenge, or I would say this was more of a lesson learned, right? That when we started looking to AppSync, right? So as we mentioned, like we have a lot of SDKs that allows you to connect to AWS services. We also do have a AWS SDK for AppSync, but currently it does not support GraphQL, right? So essentially, if you want to use a GraphQL hosted by AppSync, you will have to look at a third-party packages, and GraphQL.client is one of the readily used NuGet package, and we do have a sample code. If you're interested to see how you can use an AppSync, we can show you that. But essentially, what I'm trying to say is, if you want to use AppSync, you can use this NuGet package to be able to send GraphQL requests to talk to AppSync.
So let's look at what we built.
Yeah, let's go there now, right?
So this is the current reference architecture, right? This is what we currently have up and running. When you click that, deploy and you have that build out, I think it takes about 20 minutes usually to have the whole thing up and running and built. This is what you have installed. And if we look at this front end area, right, back to there's no right way, but there are wrong ways. I don't know, maybe this is a wrong way, because we do have some of the things that we don't want, like we have that sticky connections on the load balancer, which means someone's going to have to refresh if their Blazor on the server dies, right? So it's not exactly what we wanted, but it was the easiest way to get things to work without that cryptographic API there today. And so this is our front end GUI. The really cool thing, I'll let you talk about the back end, is that we didn't have to make a change at all to the back end. And so I'll let you go into that.
Yeah, no, I think that's exactly what Brian is like. So as we're showing what we wanted to build, right, the backend remains the same, right? We still have all the Lambda functions written in .NET, and then we can deploy those using step functions that provide the resiliency and retries, right? So all the backend still remains the same. As when the photos get uploaded to an S3 bucket, it triggers an S3 Lambda that triggers the step function, right? So the backend states remain the same as you said. Other change that you would see is like as AppSync also has a subscription model. Since now we're not using AppSync here, we added an API gateway to open a WebSocket connection to do the live updates, right? So that's other change that you would see that in your deployed infrastructure once you deploy the application.
Yeah, I guess one more thing to state about our previous architecture versus this architecture. Our previous architecture was a lot less expensive. If you look at API gateway is about $10 more than AppSync. And then if you look at the real expense there is the Fargate containers, because the container does run a container. It can certainly scale up, but it's basically running a container server, even though there's, we're not paying for the whole host. We are still running container all the time. And that does add about $100 a month in cost to our application here. So our previous architecture is a lot better from a cost, and we certainly would rather do that, and we will move to that when we have that cryptographic support. So are we going to look at observability now?
Yeah. I think just one more thing to add here, right? So I think the other good thing that I see in this current reference architecture is, let's say the customers are still running, the MVC, or they're running a .NET Core MVC applications, right? They're not up to the Blazor yet. This reference architecture could be used for those kind of applications, right? Where you are running your MVC application on a server, they're running on an AWS Fargate, and then using your front-end applications to deliver the UI component, right? So this would actually meet the need for the customers who are looking for MVC kind of stuff.
In some ways, we should have done this on purpose, right? So that we could have this discussion with people who are doing application modernization, because certainly we wanted to, have this as a framework for people to look at when we're talking about app modernization. You can look at how would you do a greenfield app, and certainly that is why we first built this. But the other thing is, when people modernize, they need to understand these concepts as well, and what can we do to modernize. And one of the things we could do is we could put their old framework app into that Fargate container and build the rest of the environment around it.
Yeah, definitely. I think this could be.
We should have done this from the start.
Yeah. That's a great point, right? And to the point, actually, we do have an MVC front end also for this in a source code. Well, yeah. Let's go into the observability, Brian, as you're saying about. I think that's one of the other cool thing that we can that we have in this app.
Yeah. So for serverless applications, I've been a server guy for a long time. So my thought was, all right, I can't remote into the server. I can't look at the logs. I can't go and check what processes are running, how much memory is utilized. Oh boy, it's going to be hard to really get the full understanding of what's going on in my application when I go serverless, right? Because I'm so used to a server and logging into that, right? So microservices and serverless type work, isn't that going to be hard for us?
It is, especially also when you go into building the distributed components, right? Let's say, as we're showing about, right, we have multiple microservices running in a container. You have multiple Lambda functions working together. How hard will it to be really see how these are connecting, or where's the latency coming from? Which could be your, the one point that is causing your latency or a bottleneck.
If only there was a company that could build some tooling there to give us that insight into that and to see how they connect. That'd be really cool.
That would be really cool. And also, this is one of the things that I've learned with a lot of customers, right? When they're building the modern application, this observability is a key point for our customers to go live. They wanted to have this observability of their application just to see all the connections, right? So with that, let's go into the demo.
I was just going to add on to it. You need that observability. Like, for example, if you're going to do what we reference with Netflix, if you're going to implement code thousands of times a day, you need that observability to see of the change I just made, right, in my little area of my app I need that feedback to say, did I just make the app a lot slower? Did I make it faster? Did I, do I need to fix something going forward? Do I need to roll back? And these, you need the tooling to be able to give those ideas to the people that are putting those changes in. And observability gives us that.
Yeah, and performance is a big thing, right? As we release the code with these microservices, we want to make sure our application performs well and be able to quickly find those areas, right? So with that, let's go into the observability demo and let's see how it looks like from the step functions. And I'm back into the management console and I'll show you the observability that comes out of the box using step functions, right? As we mentioned about running the processes in the backend. So here is our step function that is deployed. And if you click on that, you will see all the execution history of uploading your photos and being processed, right? So you can see all the photos that has been processed and the executions of those, right? And you can see if the status was successful or failed or in processing state, right? Okay, now as we talked about the step function, right, and all the functionality that it provides, but if you want to know more, right? What if you want to see how long your function took and what exact steps your Lambda function took? For that, we have another service called X-Ray, and that can give you more features. Like it could give you more traceability of your application and can see the whole service map of your applications. Let's go there, see how it looks like. So go to X-Ray. And let's go back to 1 hour or 2 hour and give it a second for it to compute the map. So essentially what we're going to see is we're going to see the service map of your application. And this is like your living reference architecture of the application, right? As Brian and I was showing you the the reference architecture, what we wanted to build, and what we built. But here you can see the whole service map, right? You can see the connectivity of these Lambda functions, how the requests flow in your system, right? As the photo is uploaded, what exactly being done, right? So once the request comes to an API, what does it really do, right? It stores the data into DynamoDB and then uploads the photo in S3 bucket. And as we talked about step function, right? You can click on the step function and you can see all the connecting lambdas that are executing to really process the photos, right? So this essentially becomes your living reference architecture. And the other cool thing that I like about an X-ray is, let's say you have a developers in your team that want to make changes to a smaller components, right? And they're not sure what other components would be affected. Essentially, they can come to the service map and they can click on one of this functionality, right? Let's say if you're changing something in your bucket and you want to make sure nothing in your application is affected, you can essentially click on that node and really see what's connecting and what needs to be tested before they can release it out, right? So it helps you with testability, knowing what components could be changed or needs to be changed when you make a change to it. So also, as we talked about, going deeper into looking at how long your function take, right? So with those, you can actually go into the traces, so and see how long your functions are taking, right? So let's say I want to see how long my step functions are taking, right? So I can go exactly into trace. I'm not sure if do I need to zoom in? I think it's probably, let's zoom in a little bit. There we go. So let's say if I want to see how long my step function took, right? So that's where you will come into traces, and you can see exactly how long your step function take, right? So let's say if I go into this image processing workflow.net, I can see it took around 2 seconds to process the whole workflow, right? And if I want to see why it took a 2 second, and because as you can see, there's a lot of multiple Lambda functions, and we can break it down to how long a specific Lambda function took, right? So as it has like collection of like a metadata Lambda function, or you have an image check Lambda function, right? So here you can see all of these single Lambda functions and how long they're taking. And you can see we're doing parallel processing here. The image recognition kind of took like 646 milliseconds. Thumbnail creation took like 390 milliseconds. So it gives you the details down to your functions, right? And that's pretty powerful when you're looking to see what's causing a latency or what's causing a delay in your application. And now once you shortlist, let's say this is the Lambda function that you might have made a code change or you want to optimize, and you can further drill down into it by looking more specifically into that function, right? So let's say if I want to go look into more deeper into thumbnail. So I can scroll down and see what exactly my thumbnail is doing, right? I can see the invocation of a thumbnail took around like 3.6 milliseconds. And sorry, I think, yeah, right, that one. So essentially, it breaks you down with your invocation and how long it took, right? I think the better example is to look into this extract metadata function because it does talk to an S3 bucket, talk to DynamoDB and an API gateway. And you can also look down to how long a specific step in your Lambda function is taking, right? How long it's taking to connect to an S3 bucket? How long it's taking to connect to DynamoDB? And you have that much of visibility of deeper down into how your code is behaving. So now think of all of that. If you have to do that in your monolithic application, how much code you have to write to get to that much of visibility. But once you start building these modern applications using Lambda or containers, right? And if you connect those to an X-ray, you get all of that observability and be able to optimize your system and find out all the bottlenecks that you might have in your system. With that, let's go back to our slide decks.
So what I saw there was that I was totally wrong. It's a lot better to do serverless than it is to do it in log, because I don't get any of that data when I log into my server and look through my logs and look at my process monitor, right? That is real amazing detail of what's taking long, the invocation versus the execution. And when I make changes, I can really look and see the change I made. How does that compare to what it used to run like in production? That's awesome.
Yeah, and that is definitely a one big change that you see customers wanted to have when you build these modern applications, right? So with those, let's talk about some of the takeaways from today's session, Brian, right?
Sounds good. Yeah, this is one way to build a modern serverless application, right? As we said before, there's not a right way. There's wrong ways, but there's not right ways. And so multiple ways can be done to meet whatever business needs you have and to use whatever tools you have available. But this is a great design to take a look at. How do I talk to DynamoDB? How do I design my DynamoDB tables? How do I go and instantiate X-ray and have that observability? Or how do I, one of my favorite things is just running the Lambda functions there and looking at the functions and seeing the data that it transfers between one function to the next, and you can click into the details that are transferred. It is so cool to be able to pull this app apart, play with it. You could even use it as a stub to start your next project. So with that, let's talk about getting the code.
Yeah, no, I think as a show, the code is readily available on the public GitHub, right? So under AWS samples. So please go ahead and you can download the code, and this could be your starting point for building a modern applications. You can deploy it with a one click, as we show you, right?
Yeah.
So
5 clicks, but all right.
All right. So essentially, this is very quickly on this slide. So when you download the application on your local machine, this is how the source code will look like. And you can see how the serverless applications are organized for you. And if you're starting to build, this may be a good starting point to reference to how to build modern apps.
Yeah, this is an area we get a lot of questions about, right? As far as in my Visual Studio, what am I supposed to do? Each Lambda function in its own little, separate section, or do I put it all together? And this is a design of best practices. So you just load this up in Visual Studio and you can learn a lot about designing and placing your code.
Yeah, and also it has all those, code pipelines and code builds, like all the infrastructure is readily available there. If you want to deploy, and you can see the code pipelines are there. The build specs are available for you to learn how to build your applications using .NET CLI extensions. It has all the best practices of how to use AWS SDKs to connect to AWS services.